Hi everyone, my name is Mohammad Azfar Jamal and I am an electrical and electronics engineering student at Bilkent University. Today I'm going to be sharing my Physics 102 project with you all, which is about determining the resistance of a metal wire. The theoretical basis of this experiment is measuring the resistivity, as I mentioned. The resistivity of a material is a fundamental property of a material which measures its opposition to a flow of electric current. This is based upon the Ohm's law, which states that V equals to IR, where V is the voltage, I is the current, and R is the resistance of the material. And we use it together with another formula which relates the resistance to the resistivity of the metal of a uniform metal wire. The R This formula states that R equals to rho L over A, where rho is the resistivity of the material, R is the resistance, L is the length of the wire, and A is its cross-sectional area. We will use these formulas together to calculate the resistivity of a uniform metal wire. For this experiment, the apparatus we need consists of a micrometer screw gauge, which we will use to determine the diameter of the wire and calculate its cross-sectional area. We need the wire for which we are calculating the resistivity of, which is connected to a meter rule. Then we need crocodile clips to make the connections, a power supply box, two multimeters, one of which is acting as an ammeter and the other is acting as a voltmeter. Using this experimental setup, six sets of readings were taken for voltage and current with varying length L, and then the resistance was calculated for each of them. Furthermore, five different readings of the diameter of the wire were also taken, and the cross sectional area of the wire was also calculated. A graph of resistance against length was then plotted, which confirmed the expected proportionality. The resistance increased linearly with length. The gradient of the best fit line on the resistance versus length graph was calculated to be 26.58 ohms per meter. Multiplying this gradient by the cross-sectional area yielded a resistivity of 1.41 10 to the power of minus 6 ohm meter. This was in line with our expectations since nichrome wire has a resistivity between 1 and 1.5 into 10 to the power of minus 6 ohm meter. However, for the calculation of percentage error, the mean of these values was used, and the percentage error was calculated to be about 11.34%. This error arose in our experiment due to inaccuracies in measuring the length, diameter, voltage, and current. There were fluctuations on the multimeter when measuring the current and the voltage, due to which it was not possible to get one true value of current or the voltage. Furthermore, the connections between the wires using the crocodile clips, they might not have been that efficient. Uh, and also we might have neglected some of the internal resistance of the power supply. Furthermore, we also need to realize that the resistors are temperature dependent, and slight variations in the room temperature could have led to changes in the value of the resistance. In the future, I can minimize these errors by using instruments which have a higher precision, and I can take many more readings to get a better average. And the experiment should also be conducted in a temperature controlled environment. But despite these causes of errors in our experiment, the percentage error was relatively low, which led to a successful experiment. And the results of my experiment confirmed the relationship between the resistance and the length of the wire, and they led to a value of resistivity of the wire which was quite true to the actual value of the resistivity of nichrome wire, and therefore our experiment was a success. And yeah, that's about it. See you.